Welcome to the 10th lecture from chapter number 9. We are studying VLSI design and we'll continue studying dynamic CMOS. Here's a small recap before we solve two examples today. The recap is, it's a general structure of a dynamic CMOS circuit. We have this NMOS array, the same NMOS array as we have in CMOS, this one, plus two gating transistors. The upper one is the PMOS, the lower one is an NMOS transistor, and they are connected to a phi, where phi is a clock which turns on and off. And we have studied that there are pre-charge and evaluate modes. These intervals, they refer to pre-charge and evaluate modes. In pre-charge mode, when phi is 0, this PMOS is on and the output is VDD. In evaluate mode, when phi is on, this PMOS is off and this Mn is on, and whatever is the combination that suggests the input is applied here, whatever is the input, the output, the function of that input is the output of the circuit, right? And the output is valid only for during this evaluate period. Right, so in this lecture we are going to study two different Boolean expressions. We are going to implement two different Boolean expressions using dynamic CMOS. So here is the Boolean expression. We see the variable a can be taken as common, so a and b or c. Right, now this function can be implemented using this general structure. We'll implement the NMOS array, and we know to implement NMOS array, we make a complement, we implement a complement of this expression, that is b or c, and then this is ended with a. And this is the PMOS array. Now we should attach this MP and Mn, the gating transistor that we require for this dynamic CMOS, right? So now we have to implement this MP here, connecting it to VDD, its source terminal, and then an Mn, the same MP, the same Mn, and we'll connect it to the clock phi. This is one of the two circuits that we'll implement. We have to implement in this lecture. The second circuit is the implementation of this Boolean expression. Capital F is A and B or C or D. So we have to implement only the NMOS array, for which we implement its complement. So the complement is A and B or C or D. So B or C or C or D. Ended with A, and then the two gating transistors MP and Mn, maybe with a different color. MP connected to VDD, and Mn transistor, its source is connected to ground and the gates are connected to phi. Right, this is all for today's lecture, and in the next lecture we'll be studying domino logic. Thank you.